Hey everybody! Today we're going to be talking about perimeter and area in similar figures. This is 10-4. You can use ratios to compare the perimeters and areas of similar figures. Check it out. Okay, here's the ratio, how we would write the scale factor. It's the format for it. You have this part compares to this corresponding part over here. This is the ratio of perimeters. If I had one side that was 3 and maybe on one shape, and then on the other shape I had 6, then I would put 3 to 6. This is the format that would go. If it's the ratio of areas, I would take, if the measure of the inside, I would just square each of those things, and that would actually get like the sides, and that would give me the ratio of areas. So problem 0. First of all, are they similar? Polygons are similar if they have congruent angles and proportional sides. So here's a couple examples. Let's see if they are. Let's see if you can figure out which ones are congruent or which ones are similar and which ones are not. Do they have the same angles? While they're not marked, I would say that they look like they do. I'm noticing that 6 is proportional to 12. That's like double. 8 is proportional to 16. That's also double. And then 10 is also double, 20 is double of that 10. So these are proportional sides. Yes, those are similar figures. So this one has, they are definitely proportional sides because they're the same. 2, 2, 2, 2, 2, 2, 2, 2. But check out the angles. What does it say about congruent angles? Polygons are similar if they have congruent angles and proportional sides. So we have the proportional sides for sure, but we don't have the congruent angles. 60? No, these are 90-degree angles over here. That's a no. Here's another one. Here's a couple rectangles. Looks like I have the congruent angles. Everything is 90 degrees. 8. Wait, so check out so 8 to 18, well, that's 10 different. 12 to 24, that's double. Well, double 8 is 16, and that would be, this one is not proportional. That's a no. Here's another one. Boy, those look very similar. Let's check out all the angles, make sure that they're the same. 105, 120, 105, 120, 90, 90, 45, 45. Those are the same angles. Let's check out and see the sides. I have 11. I have 110. That means 11 times 10 equals 110. Let's see if they are all times 10 to see if they will be proportional. Is 15 times 10 150? Yes. Is 4 times 10 40? Yes. Is 8 times 10 80? Yes. That's a yes. Those are similar. Here's a different kind of problem. Finding ratios in similar figures. Let's figure out how to actually come up with the scale factor. Scale factor, remember, is A over B. So I'm noticing this side here, I have a 1, and the similar side, the corresponding side, is a 2. So I just put 1 over 2. Scale factor on this one, let's see. So it looks to me like I've only got the 9 on this one, so I'm going to have to use the 9 in my equation. So 9, and I think the whole thing is turned. So this side over here is the corresponding side, so it's got to be 9 over 2. I like to have my small side on the top, so 6 over 9. Let's put that one in. 6 over 9. Now, 6 over 9, I can reduce 6 over 9. So check out this one. Equals 2/3. I can do that because both 6 and 9 are divisible by 3. So if I divide 6 by 3, that equals 2. If I divide 9 by 3, that equals 3. All right, so finding area using similar figures. I have a regular polygon here, a regular pentagon here, and a regular pentagon here. I'm noticing that because they're regular, they're always going to have the same angles, so congruent angles, good to go. They have different sides though, 4 to 10. Okay, so I'm gonna go ahead and use those to come up with a scale factor. But first off, I have been given that the area of the smaller polygon is 27.5 centimeters squared. The scale factor, it's 4 to 10, 4 over 10. I can reduce that because both of these numbers are divisible by 2. So let's go ahead and do that. When I do that, it makes the numbers smaller and easier to work with. So 4 divided by 2 equals 2. 10 divided by 2 equals 5. 2/5 is my scale factor. My area ratio then would be 2 squared over 5 squared, because remember, area ratios, we just square everything. So what does that equal? 2 squared is 4, and 5 squared is 25. So my area ratio is 4/25. Then I take my 4 over 25 and I bring it down here and I actually write out my proportion. Here's the scale factor, here's the proportion. The whole thing is the proportion, but I refer to this side a little bit as the what we're working with. So the smaller one, all my small numbers are on the top. All my small pentagon numbers are on the top. All my large pentagon numbers are on the bottom. So what I do here is I have the 27.5 here. I don't know B. I'm trying to find B here. So the way that this is done is we cross multiply first. 25 times 27.5, that's a big number. And then 4 times B is 4B. So that's going to be 4B equals 687.5. Now, the next step is to divide, because if I want to get rid of this 4 here, I have to divide both sides by 4. That cancels that out, and it leaves me with B equals 171.875 centimeters squared. Pay close attention to those arrows up here, because this can all be really simplified if you get used to just going through this sequence. The mantra to know for ratios: cross multiply and divide. Cross multiply and divide. So when I have this ratio, this proportion again, I would the people who do this quickly with the calculator without having to write anything down, they just go 25 times 27.5, and then they divide it by 4. And that gives you the answer. Now check out this problem 3, finding perimeter ratios. The triangles here are similar. What is the scale factor? What is the ratio of their perimeters? All right, let's figure this out. So if I have a squared over b squared, then that means that these are squared measures. So the area is 50 over 98. Now, as I look to that, it's really helpful to be able to reduce these specifically to squares. So check out the yellow parts here that go along here. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. People have these memorized. So I recommend that you get to know your squares to 100. But it will actually, this chart will be on your page. So what I would like you to do is I would like you to go ahead and put the 20, I take the 25 and the 49, I get that just by cutting it in half by dividing each number by 2, 25 over 49. Then I go ahead and I reduce that to 5 over 7, because I can divide this one by, because I can go right to the perfect squares. So if my perfect square here is 25, that would be 5. If my perfect square here is 49, that would be 7. Then I bring that down and my answer would be 5 to 7. That's it. All right, get after it.